condescendingly is a good thing as an accountant. We didn't really appreciate that. But, yeah, no inheritance. So anyway, if I'm doing my presentation on terrestrial sequence stratigraphy, we're going to look at just fluvial systems more so. You can also apply this to eolian systems, but we'll just use the fluvial systems as an example. So we're kind of going to go through overall just how marine sequence stratigraphy can apply to the terrestrial realm. And then, but just first we'll talk about some difficulties, because you can't always take the concepts of marine sequence stratigraphy and take them up on the shore. We're then going to talk about just some controls of fluvial processes, which will help explain why we can't always talk about sequence stratigraphy in the terrestrial realm. And then we'll use two models. One is the application of marine sequence stratigraphy to land, and then the other is when the fluvial systems are isolated, or you just can't see the change in base level and how it affects the fluvial system. But we need to keep in mind that if the deposits are isolated from the shoreline, you're not going to see, or you may not know that base level is affecting the changes in the fluvial system. And if the deposits of the fluvial system are too far away, then it's not going to change or feel the change in base level. And it's usually about tens of kilometers away. I think when I was reading, the high was about 130 kilometers, but it's usually below that you stop feeling the influence of sea level. And then also, on the outcrop, it's determining if it's an autocyclic process or an allocyclic. It can be kind of hard to tell. Maybe the channel just evolves instead of the system changing, but so you always need to be careful with that. Make sure that it's allocyclic processes that are going on. So here are the main controls on the fluvial deposit. These four. We have the source area, where it's uplifted, the climate, the basin substance, and eustacy. So you can just see that this figure is just showing, basically what I want to show is just how many different types of fluvial systems you can get. There's a lot of differences so for example, basin substance, if the tilt is high, you can get high sinuosity. If it's low sinuosity, or sorry, vice versa. If it's low, you'll get high sinuosity. If it's low, you can just have a straight channel. UC can affect if it A-grades or if the fluvial system incisors. And then the climate will usually affect how much discharge of water you get, while the source area is the type of sediment that will be produced or moved. So here in this figure we have a mountain, obviously. Here's the hinterland, here's the sea, and this is the fluvial profile gradient. And up here, this whole column is just representing 100% of what's controlling the fluvial system at each point. So towards the hinterland, you can see that it's a lot more. There's basin subsidence that's affecting it, source uplift, and the climate. As you go more basinward, a lot more of eustacy happens and less of the source uplift, and a little bit less of the climate. So more seaward, we have eustacy and basin subsidence affecting the fluvial systems, and more landward towards the hinterlands, it's more climate and source uplift. This point is the landward extension of the fluvial system reacting to eustacy changes. And anything below this line that's affecting the fluvial channel is called a downstream control. Anything above this point is the upstream controls that are affecting it. So now that we know some of the controls, we're going to apply how the controls affect the fluvial systems. We'll first talk about if you can establish a relationship between the fluvial systems and the base level and the fluvial shoreline. And then we'll also talk about if you can't, if the fluvial channels are isolated or too far away, or if you just can't apply, you're not sure if you can apply to marine sequence stratigraphy. So here's some basic first principles of fluvial sequence stratigraphy, just to kind of get us warmed up and to summarize a little bit before. So during times of sea level fall, we'll get incision usually, and we'll get fluvial aggradation when there's base level rise because of gradient changes and becomes lower. And we'll have low sinuosity systems during when the sea is at a low stand. And then we'll have anastomosing when the sea level is rising pretty rapidly. We'll have meandering systems when the sea level is still rising, but it's at a more slower pace, like during the high stand. And the incised valley can be filled with all types of the fluvial system, so like each type of tract. And then we can also see marine influence on fluvial systems. when there's a maximum flooding surface or just a flooding surface, you can see how the fluvial systems have been kind of reworked to have tidal facies such as hydrolithic strata and things like that. But we'll get more to that in a little bit. So first we're going to talk about the sequence boundaries. They can kind of be hard on the terrestrial realm because incision may not always occur. There may be sediment bypass instead. It kind of depends on a few things, which I'll show you in a minute. And then there's also within incised valleys, the terraces can be kind of complex, and it can be hard to like pinpoint the location of the sequence boundary. But usually we still interpret sequence boundaries from incision, from erosion. But you just need to be careful because it can be just bypass and no incision. So here's a figure that's showing when incision will occur and when it won't. Basically, incision occurs when you have a shallower gradient alluvial plain, and then it gets to the marine shelf, and there's a huge change in gradient, and it gets steeper. Then the gradient of the river will change, the profile will change, so that there'll be a higher energy. And so we get incision here. Here, this is just a constant gradient, there's no change. And if the sea level lowered, it would just be mostly sediment bypass and not as much incision. There may still be a little bit of erosion, but it's just a lot more sediment bypass. And here's the opposite extreme. You can have a steeper gradient from the alluvial plain go into a shallower gradient, and you'll actually get deposition at that point, but you'll still have a sea level fall. Another factor that affects incision is just by how much sea level falls. So with this first one, if we took sea level that's right here and dropped it to here before the break, it would just be sediment bypass because there wouldn't be a change in topography that would change the fluvial profile and the energy of the system. This is just another example of kind of what happens during sea level as it falls in incision. So here we have the deposition of like the high sand systems tract, we can think of it as, and there's a depositional scar. And so we have sea level at 1 right here, and it drops to 2. And you can see that there's a huge topographic change here, so the fluvial profile changes, and so the energy increases of the system, and it erodes down. You can see the incised valley. But here, this is subaerially exposed, but it's just sediment bypass that's going on because the water is right here, not down here, so the gradient of this part hasn't changed. As we drop sea level further and we get below this shelf break, then we start to see incision, and then as we even go down further, we start to see more incision. Incision usually starts more basinward and then will migrate upshore, so you can kind of see the figure part from B to C, how it starts here and then back steps upstream. So to see a maximum flooding surface, there are two main things you can look at. One is you'll just see a lot of the tidal influences, which I kind of mentioned before. So you'll see like flays of riffle lamination, riffles, herringbone cross stratification, and just a lot of kind of tidal facies that are superimposed on the fluvial deposits. Another big thing you'll see is a change in the energy of the fluvial system. So you'll go from meandering, which is this yellow, to braided, which is this orange above, so like in this section. And that's just because the maximum flooding surface makes the sediment step back and then starts prograding again. And so we get braided over meandering systems. So now we'll just talk about the systems tracks, and just keep in mind that you can only use this terminology when you can establish the relationship with the shoreline or the shoreline facies. And it's usually an exception. Usually, this is kind of more difficult to see in the rock record, but it can be done. So in the high sand systems tract, we have two parts, kind of like we do with just marine. There's a lower and an upper. The lower high sand systems tract, or the sea level rate, is more or equal to the sediment supply, so the sediment's A grading, and it's usually in isolated channels and floodplain deposits, and so we have a low sand to mud ratio. And then once sea level starts to slow down towards the top of the Milankovitch curve, the sediment starts to outpace the rise in sea level and the accommodation space made, and so sediment starts to prograde, and we get a higher sand to mud ratio, and the channels begin to amalgamate vertically, and they also interconnect laterally. In the falling stage systems tract, there's not much deposition. Usually, in most cases, the sea level will fall below a huge topographic change, so just kind of the incision will happen because it'll go from shallow gradient to a higher gradient. And so we'll get incised valleys, and we can get incised meandering belts, which is kind of interesting. It's just the river is following the topography kind of made by the high stand meanders, and so it can, the high stand systems tract meandering belts can kind of be preserved their morphology, which is kind of interesting. There are still times where it may be unincised just because there may not be a huge change in gradient as sea level falls. If it was just, that constant gradient that goes down, there was no change. And you're going to have mostly sediment bypass, but at this location you would see, if you're looking at it during the time that it was happening, you would see there'd be meandering systems, then when sea level fell, it turned more into braided. So, and you can see the braided and things just because it's not following the topography of the high stand meandering system before, since there's no incision. So in the low stand systems tracts, we have sea level kind of start to rise with sediment still outpacing. There's a decrease in grading, so as we go up through section, there's a decrease in grain size, and there's also a decrease in the sand to mud ratio. And a lot of the low stand systems tract sediments accumulate, if there is an incised valley, in the incised valley. And the transgressive surface, we just have a lot of the water's rising really rapidly, and we have a lot of accommodation space, like on the coastal plain. Not much is going out to the basin. And also here is where we have fluvial tidal influences of the fluvial system. The sand to mud ratio decreases upward, and the channels become more isolated as we go upward. And so just a decrease in amalgamation upward too. You can also think about it. So here, I put this in the summary if you have it. This is just a figure. This line right here is the one we're concerned about. It just talks for each systems tract. It just says what happens to the maximum grain size and sand mud ratio as it goes from each systems tract. And we've gone over this, but I just thought it'd be good for you to have. And here down here, it just shows, it summarizes what we've talked about. So I just thought you might like to have that. So here's kind of a model of a fluvial sequence. We're going to start down here at the falling stage systems tract. So the sequence boundary is right below this. And you can see here that we have incision, so the sea level fell below a big topographic change. And there's really no sediment. You get some terrace developments, but all the sediment is down cutting and moving out towards the basin, kind of like that volumetric partitioning that we've talked about. During low stand, we start to see amalgamation and multi-story channels start to fill up in the incised valley. And as sea level begins to rise, we get the transgressive systems tract. We get some amalgamated channels, but then it becomes more isolated as we go up section because the energy and the fluvial gradient is changing and lowering. And these blue deposits just mean they're being tidally influenced. So the sea is kind of right here being affected by, or the fluvial is being affected by the tides. So it's pretty near to the shore. And then we go into high stand, where we have more meandering, more isolated channels at the bottom, and then as sea level starts to slow down even more, then we get more progradation and amalgamated channels. So when we can't apply those systems tract terms and those concepts and ideas to terrestrial sequence stratigraphy, we do something else that's called accommodation systems tracts. We use different terminology, and it basically is just based on changes in fluvial architecture, and the architecture is due to changes in accommodation space and sediment supply. So first we have the low accommodation systems tract and the sequence boundaries at the base of the systems tract. And during this time, there's not much accommodation space at our location. It's all more seaward. So we're having a lot of bypass of sediment, especially mud. But we still see a lot of sand they put here, so there's a high sand to mud ratio. It's more braided system, so they're multi-story, they stack, and the deposits prograde. The next systems tract is the high accommodation systems tract, and this is kind of the opposite of low accommodation. The accommodation space is now near our source or where we are, and the deposit's A grade, and we have the energy decreases quite a bit, so we have a low sand to mud ratio. And also at the bottom of this, we have the expansion surface, which is just where accommodation space increases quite significantly at our location. So here's an example. We've seen this figure before, but it's a good figure to kind of look at. So the red are the low accommodation systems tracks, and the blue are the high accommodation systems tracks. And at the base of each low accommodation, we have a sequence boundary. And at the base of the high accommodation, we have an expansion surface. So you can see how it goes from really sandy to, there's still sand, but a lot more mud, really sandy, little sand, and a lot more mud. So in conclusion, there are many differences between marine sequence stratigraphy and terrestrial, but there are similarities. You just need to be careful, and when you're applying the marine sequence stratigraphy concepts to the terrestrial realm. And when you can apply, you can establish a relationship between the fluvial deposits and the coeval shoreline deposits. You can use the terminology that we've learned in class, the high stand systems tract, low stand systems tract. But it's more common that the deposits you may not be able to establish a relationship, or they may not be affected by sea level as much. So you use the accommodation systems tract language, which we just kind of gone over quickly. Thank you.